So I'm going to take a couple minutes and go over the homework that would have been due today, and then we'll look at the material for 6-3. So last night's homework, you had to name the property on the first three. If you look at what happened here on number 1, as you moved from the left to the right, the location of these two fractions was switched. And when you change the order across addition, that's called the commutative property. So that's what your answer should have been for number 1. Number 2, what was inside of the parentheses switched. The order stayed the same, 1/3, 2/5, 4/3, 1/3, 2/5, 4/3. But the parentheses moved from around the last two to the first two. So that is called associative. And on the last one, you took a fraction and added a fraction that was equivalent to 0 to it. They had the same denominator, but you ended up with the same fraction. That's called the identity property. So you want to make sure you know all the properties for the quiz, but there's an example of 3 of them. Then you had to do some solving, and you wanted to think about the properties and how they might help make that easier. So, for example, rather than subtracting two fractions that have totally different denominators, like 1/9 and 1/5, these two fractions, if you multiplied the denominator of 1/9 by 3, you could have the same denominator pretty quickly. So I'm going to choose to use the associative property and add 8/27 and 3/27 first. That's just a choice I'm making. I don't have to do it that way, but I'm just choosing to do it that way. And if I do that, I end up with 11/27. Now I still have to subtract away a 5th. So I'm still going to have to get a common denominator at this point. I don't have a way around it, but at this point 27 and 5 have no common factors, so the fastest way to get their denominator would be to just multiply 27 and 5 together, and so make my denominator 135. And then remember the way that the subtraction property works is you could take 11 times 5, because that would make this fraction have the right denominator, minus 1 times 27, which would make the second fraction have that denominator. And then you could finally subtract, keeping your common denominator, and get 28 over 135. The second one, I noticed that 36 and 18 would be easy to get a common denominator for, so I'm going to use the commutative property to switch the order of these two. Over here, remember, you didn't need the commutative property. You didn't change order, just parentheses. So it was associative here, commutative here. And then these two, if I want to add them together, have a denominator of 36, which would be the common denominator. First fraction doesn't change. Second fraction, I multiplied the bottom by 2, so I'll multiply the top by 2. And now I need to take 11/36 and subtract 2/5 from it. This is that 2/5. So again, no common factors between 36 and 5, so I'll multiply them together and get 180. And then 11 times 5 minus 2 times 36. And I'm going to end up with a negative numerator, and it'll be negative 17, I believe, over 180. So those were the first two. For number 6, we talked about the fact that you could keep them as mixed numbers, and that's the way I'm going to do it. I'm not going to turn them improper, although if you did turn them improper, that's perfectly fine. But I'm going to change the order again because I want to add the two positive fractions together, and then I'll take away the other fraction. So commutative property, just keeping my signs where they belong. There's a plus in front of here that I don't write. There's a minus in front of the 3 and a plus in front of the 5. So when I put these two together, I need to think about the 1/5 as 3/15, so I can add it to the 5 and 8/15 and get 10 and 11/15. So I'm adding the integer parts and I'm adding the fractional parts. Then I'm going to take 10 and 11/15 and subtract 3 and 2/3 from it. So I need to think about the 3 and 2/3 as 3 and 10/15. Multiply by 5 on the bottom, so multiply by 5 on the top. When you subtract, then you'll get 7 and 1/15 as your final answer. If you did it with improper fractions, you should have ended up with the same equivalent fraction. Now for number 7, I'm going to choose to keep it in the order that it's in. So that means that I'm going to need a common denominator inside the parentheses, and I'll make that a denominator of 6. So the second fraction won't change, but the first one will change to 4/6. And then that will lead me to 7/8 minus, when I subtract, I get 3/6. So I'll have 3/6 here. But now that I'm going to have to subtract these two, I'm going to realize and write down that 3/6 is really a half. Otherwise, I'm going to go get a common denominator between 8 and 6, and I really don't need to. I need a common denominator between 8 and 2 when this is reduced. So that'll just make it a little easier. 7/8 minus 4/8, and I'll end up with 3/8. And the last two, number 8, I need a common denominator. I'm going to keep them as mixed numbers, but I need to turn the 4/5 and the 5/9 into fractions that have the same denominator. So I'm going to change this to 7, and common denominator will be 45. And I multiply 5 by 9, so I'll multiply 4 by 9. And down here, to make 45, 9 times 5, so 5 times 5. Now I'll subtract my integers, and I'll subtract my fractions, and end up with 11/45. So the answer is 1 and 11/45. And then finally, the last one, looking at this, I want to use both commutative and associative, because I really would like to add the two terms that have ninths in them. So I'm going to put the 4/9 and the 2 and 5/9 together. Commutative because I changed the order. I moved this over here. Associative because I also changed the parentheses. So then the 2/15 is going to wait here for me to figure out what's in here, and then I'll add it. So when I add 2 and 5/9 to just 4/9, I'm going to end up with 2 and 9/9, and that's going to really be the number 3. So at this point, I'm taking 3 and adding on 2/15, and that looks like this. 3 and 2/15. And that's the final answer for that. Much quicker because I added together the things that gave me that 1, and that made life much easier. So that was your homework. We can answer more questions about it on Wednesday if there are any. And then what we were going to do today is section 6.3. And luckily that's multiplying and dividing fractions, which is easier than adding and subtracting. So if you are going to multiply any two fractions together, they don't need a common denominator. You can multiply the numerators and multiply the denominators, And then maybe you'll have to simplify afterwards. And by maybe, I mean if there were common factors in either A and D or B and C, then those common factors will have to be divided out at some point. Dividing fractions. If you are dividing fractions, you always want to change the problem to multiplication. So you're never technically dividing fractions if you turn it into a multiplication problem by flipping the second fraction over. And so A over B divided by C over D is the same thing as A over B times D over C. And then you can do what we set up here. Just multiply the numerators, multiply the denominators. The closure property of fraction, this is a typo, it should say multiplication, is the same idea as we talked about previously, that if you multiply two fractions together, you will always get a fraction. And we talked about that on Friday as well. Commutative property we talked about on Friday, and it works for multiplication as well. You can change the order of any two things that you're multiplying, and you will have an equivalent statement. The associative property we talked about as well, and that says that if you have parentheses around two factors, and then you multiply on a third factor. Now I'm using the word factor because when you have things all multiplied together, they're called factors. On your homework, we were calling them terms because they were connected by addition or subtraction. So that's an important idea, that if you have 5 times 6, you would call each of these factors. But if you have 5 plus 6, you would call each of these either terms or addends. Two different words for the same thing. Term technically we use when we have algebra involved. And so even if you can't add them together, if there's addition between them, you would call them terms. So it's just a little aside. If you have two factors in parentheses and then a third one multiplied on, then you can move the parentheses and have them surround the second two factors, and you will still have an equivalent problem to solve. We had an identity in addition. Now we have an identity for multiplication. It is the number 1. So if you take a fraction and you multiply it by 1, you don't change the fraction. And sometimes 1 can look like 7 over 7 or 10 over 10. So, I'm sorry, this one. 7 over 7 or 10 over 10, that 1 doesn't always have to be in its final form of 1. It just has to be something equivalent to 1. And so this is why we have m over m here, but m is not 0. You never want to forget 0 over 0 is not 1. So if you want to use 1, you have to use any other number over itself. The multiplicative inverse property says that for every fraction there will be another fraction such that they will multiply to 1. That's what's in the book, and what I want to add to that is, hopefully you know where I'm going already, but there is one number that can be written as a fraction that does not have an inverse. So I would add this, even though it's not in the book, except for 0 over b. 0 over b, which is 0, does not have an inverse, because there's nothing that you could multiply by 0 and end up with 1. Okay, so every fraction other than 0, and that's what they mean by non-zero. So instead of just sticking that word non-zero there, I think it'd be important to make that statement. And we use that inverse to multiply to 1 when we're solving algebraic equations. So we talked about that a little bit as well on Friday. And then there's this new property that we didn't talk about on Friday because we were only dealing with addition, But if you have three fractions and you put one of them times the sum of the other two, and that's what this looks like, then you have this new property called the distributive property that says you could multiply before you add. So even though the parentheses say add these two fractions together, the distributive property says, well, you really could decide to multiply and then add. And sometimes that'll make the problem a little bit easier. So, it's your choice. But for example, if you had 8 times a half plus a fourth, and you use the distributive property, then you could really just add 4 and 2. Because when you multiply 8 times a half and 8 times a fourth, you get rid of the fractions. And so there's a situation where the distributive property could help you not have to add two fractions together. Okay, so this is a new one. All the other ones we dealt with respect to addition, so they should sound a little familiar. So there's a couple examples that I want to go over, and then your homework for tonight will also be a worksheet that is on Angel, and it's a worksheet on 6-3. So these should help you be able to do that, and then we can go over questions on Wednesday before the quiz. So if you're looking at example number 1, and you decide that maybe I should switch where these parentheses are to make the problem easier, and maybe I should, maybe I shouldn't, but the deciding factor to me is that these 5s will divide each other out. So if I choose to use the associative property, then I will divide out this 5 and this 5 before I even multiply. I can divide out this 2 with this 6, and then I'm going to be multiplying 3/7 times, I got 1 times 1, so that's 1 on top, 1 times 3, so that's 3 on bottom, sorry. And then again, before I actually multiply, I could divide this 3 with this 3 and end up with a 7th. I'm going to get the same answer if I take 3 times 2 times 5, which is 30, over 7 times 5 times 6, which is 210. Same answer. However, dividing out before you actually go and multiply is going to be a good habit for your students to be in, because it keeps the numbers smaller, and it's going to help them when they hit algebra and they need to understand that they can do some dividing out to make their problems simpler. So I want you to be working on that. If that's not something that you're comfortable with, you usually just multiply and then simplify, I want you to try, as you go through your homework, to do the dividing out. And remember, we're not using the word cancel. We're going to say these two 3s divide each other out. They divide each other out, meaning they divide and make the number 1. Now, number 2 is tricky. You have to think carefully about number 2, because you know that 2 and 3/9 really means plus 2 plus 3/9, and 5 and 7/9 really means 5 plus 7/9. And so if this is what that problem really means, then you can't just multiply the 2 and the 5 and the 3/9 and the 7/9. Because the distributive property would say this 2 has to multiply with the 5 and the 7/9. And this 3/9 has to multiply with the 5 and the 7/9. And distributive property would lead you with 4 terms there that would all have to be added up. And because of that, the best way to multiply mixed numbers is to make them improper. Now, we just went over the homework, and when we were adding mixed numbers, I didn't do that. I kept them as mixed numbers. And you could keep these as mixed numbers if you understand how to FOIL and you're comfortable with it. 2 times 5, 2 times 7 ninths, plus 3 ninths times 5, plus 3 ninths times 7 ninths. And that's perfectly fine. But I think the faster way to go is to make them improper. So this would be the only time that I would do that, is when it's multiplication, not addition. So this first fraction, before I make this improper, I'm going to realize that 2 and 3 ninths is really 2 and 1/3. I'm going to simplify that 3 ninths. And then I'm going to multiply 2 times 3 and add 1 and make it 7 ninths. And now the second fraction, 5 times 9 is 45. Add 7 and get